from here, the first thing is that we're going to say that the integral from a to b of f of x dx is going to equal to the negative of the integral of b to a of f of x dx. Now, just to draw a drawing that's going to hopefully make sense to you, is if we go from a to b, let's just say that this curve represents f of x. If we go from a to b there, that essentially if we say this would be that cap f of b minus cap f of a would equal to the negative of cap f of a minus cap f of b. Because think about what happens when you distribute that negative into that next parenthesis. The f of b becomes positive and the f of a becomes negative, right? Okay. I'm going to come back to this one in just a minute. Let me erase it. If we have the integral from a to b of f of x dx, no, I'm sorry, f of x plus g of x dx. In other words, we're adding function f with function g, that's going to be equivalent to the antiderivative from a to b of f of x plus the dx, plus the antiderivative from a to b of f of x dx. Gx, sorry, this is gx. G of x. And in trig problems, every once in a while you'll have a trig problem that will be mixed with a polynomial, and you'll pretty much see that it's easier to separate them out and work them as separate problems. Also, sometimes we'll have one function where part of the function you can solve just regularly and part of the function you need u substitution to solve. So if you split them apart, you can do u substitution for one part and solve the other one by other means. So that is actually a property that you will use frequently in here. Now, another one that can come in handy from time to time is that if you have the integral from a to a of f of x dx, what do you think that would be? 0, yeah. There is no area there, right? If your upper limit, these are new terms, this is called your upper limit of integration and your lower limit of integration. So your upper limit of integration and your lower limit of integration, if they're the same value, there is no thickness there, so the area would naturally be 0, yeah. 0. Now, this is my favorite one from here, and it's the one I wrote down first. If you have the integral from a to b of f of x dx, it is equal to the integral from a to c of f of x dx plus the integral from c to b of f of x dx. Now, a lot of times what that c value is, now this is not necessarily true every time, but a lot of times what happens in these problems is this c value is going to be where you break from positive values to negative values. Not necessarily, but that's where it's going to happen a lot of the time. So I want us to look, though, at something. And again, we're taking into this the context of area. Now, I'm going to do something you're probably not expecting to see here. I'm writing A, B, and C in that order, A, B, C. But it doesn't have to be in this order. And again, here's my function f of x. All right. Now, the integral from a to b of f of x, and since everything up here is positive, the function's always positive, that is going to equal to the area from a to b, the area between the x-axis and the curve itself. So what this is saying is this area right here would equal to this area here plus, now, think back to what the first property said. The first property said that if we go from a to b of f of x dx, that that's the same thing as the negative of b to a of f of x dx. So, if I want to go from b to c, I need to turn this into a to b of f of x dx equals to a to c of f of x dx minus b to c of f of x dx. All right. So, based on that, what I'm saying is the area from here to here is equal to the area from here to here minus the area from here to here. Well, because of this. So it's really plus the negative because of the way I wrote it. But if you write it like this, it's plus c to b. We just see that c to b ends up having a negative value because the upper limit of integration is less than the lower limit of, the upper limit of integration, which would be b, the upper limit of integration is less than the lower limit of integration. So since the area is above the x-axis, then that gives it a negative value. But that's what's happening there. And again, you can write this in any order. The easiest order to write it in that makes the most sense is to put A here, C here, and B here. In other words, we're going to put C in between A and B. And I think it's a little easier to see like that. You've got A to C plus C to B. Well, A to C plus C to B, A to C plus C to B would equal to A to B. So that's the easiest way to see it. Are there any questions there? All right, so those are our properties of definite integrals.